Our second speaker is Andy Konwinski. He is a co-founder of Databricks, and he is a former PhD student and postdoc at Berkeley in the AMS lab. Unfortunately, I think Randy stopped updating his website, so I don't know which number he is. His current research focuses on large-scale distributed computing system comparable to Spark and Mesos. And he is one of the creators of Apache Meso for clustering scheduling. And he has been adopted by Twitter for their private cloud platform.
What do Randy Katz and big data have in common? Well, look around. They're both very popular. And speaking of big data, have you noticed how frequently Randy updates his Facebook page? I assume that Facebook has a small analytics cluster dedicated just to Randy's feed. And that's not only because of the formidable size of his Facebook page, but also because, like big data, Randy is full of insights. Probably most importantly, Randy, like big data, has shaped the path that I've taken both in my research and probably like everybody here in my career. So I'm going to talk to you about a little bit of that career, which started with Randy in 2007 at UC Berkeley as my advisor, and I finished at Berkeley with Randy in 2012. Before I joined the company that spun out of the AMP lab to work on a research project that began in the AMP lab while I was working with Randy. And broadly speaking, I'm going to cover the trends and opportunities that I see for folks like ourselves in technology. Whether you're related to big data or not, we've all participated in academia. And some of the trends that I'm going to talk about relate to academia. In particular, the final thing I'll end on is how big data and academia and education are interrelating these days. But before that, I'll talk about two other trends in big data, including the role that open source has played, particularly in the projects that I've worked on with Randy in the last 5 years, and the adoption of big data by the enterprise, and how open source and academia, or education more broadly, plays into this adoption of these big data platforms by the enterprise. So let's just jump into these three kind of trend categories. And I'll walk through a little bit. I stole slides from, as you would imagine when asked to give a talk like this, I just kind of stole a bunch of slides from a variety of keynotes and tech talks that are given around Databricks. So, but I tried to zoom out a little bit because I don't want to just give you, I'm clearly not going to give you a vendor pitch, which is what I do with a sad amount of my time these days. So we'll try and keep it about something very general around big data. But since my specific context in the big data space was particularly around open source and the projects that I worked on in the AMP lab, the way to start maybe is to relate to how open source is impacting big data and more broadly impacting technology and the adoption of technology. I think that open source has for a long time been the underdog in terms of adoption. If you think of Linux as the classic example, the momentum and investment necessary to drive widespread adoption of the open source alternative. And you notice that often it's the open source alternative and not open source leading the way with the proprietary thing being the alternative. The investment necessary to drive the adoption of open source hasn't quite been there. Now there's certain examples, the Apache web server being the most obvious, where the open source alternative is the #1 winner for the most part. But even in that case, it's the winner in certain small contexts. And then more broadly speaking, Apache or Microsoft's version of a web server wins the pie. And I think that those economics are actually shifting. I don't know how many people are familiar with big data in the kind of zoomed out broad sense. I assume probably all of us are. if you think of a big data framework or a big data tool to use, and you do an informal survey amongst technologists, you're probably going to hear the first thing they say will be an open source framework. Now, that's not to say that proprietary frameworks don't exist in the space. So a good example would be SAP HANA is a proprietary alternative to Apache Spark or the Hadoop platform. But in this time, and in the last few years, the open source project gets listed first and comes to mind first. And I think in just the activity you see around open source, around Apache Hadoop, around Apache Spark, around Apache Mesos, which are of this broader ecosystem in big data, where you see open source tools, the 3 that I worked on, and more specifically in the last 2 or 3 years, just Apache Spark. The open source momentum and contributions outweigh and not only get the attention from the marketing side of the world, but also actually the technologists and the adoption side. So I personally, being a deep enthusiast about open source software, find this to be a very exciting time in history to be alive as technologists. And I think all of us, especially with the Berkeley heritage and with Randy's influence on so many important open source projects, should be excited and probably are deeply excited about this trend and this turn of sort of the old classic open source versus proprietary software on its head. So let's zoom in a little bit on Apache Spark. It's the thing I can say most relevant recent trend data about. If you don't know what Apache Spark is, it's an open source piece of software you can download, and it provides cluster computing-based data analytics. Like any good tech talk, I have an architecture diagram. Spark Core is just this engine written in Scala that allows you to manipulate data that's spread across many, many commodity computers. And then these boxes on top of it are various computing APIs or components of Spark that give you a unified abstraction for doing data analytics. So you can write both streaming jobs, SQL queries, and machine learning applications all on top of one unified open source platform. To underscore the impact of open source in the context of Apache Spark, I'll just show some of the growth numbers that kind of I find inspiring that drove us to create a company around Spark and have influenced our strategy when trying to make money off of this open source project in how we still maintain a friendly, and not only friendly, but fostering relationship and understand that by giving back to the open source community and more broadly the world and academia and other kind of channels freely, that's how we maintain that driving force, not just on the kind of morale and moral and philosophical side within our culture, but actually also materially to our business proposition. So Databricks has something like 40-ish engineers right now, and something like 15 of them are writing free open source software all day, every day. That is part of this change that you've seen where the ecosystems, as we call them, have developers that are paid to develop full-time by large both tech companies and classic companies like Microsoft, Yahoo, and then a lot of startups. In 2014, the total contributors to Spark, number 255, 75 contributors per month. These are different individuals with 175,000 lines of code. Now let's look at 1 year after that, 730 total contributors to the project, 135 contributions per month, and 400,000 lines of code. And then if you just graph it, this is approximately what it looks like. This is not unique to Apache Spark. Many other open source frameworks that are getting widespread adoption by enterprise, academia, and whatever type of organization show growth patterns like this. I do think this is actually unique in the last 10 years, this sort of trend. Apache does happen to be the most active project in Spark does happen to be the most active project in the Apache Foundation, but this is all very cyclic, so I'm sure there will come the day when the thing that replaces Spark comes around, though we're doing our best to keep that from happening. So trend-wise, some things that just from a technology perspective, folks in this room might find interesting about the data science, the future of Spark and the medium-term roadmap are that the tools that data scientists use, so predictive analytics primarily, and machine learning and statistical learning techniques are finding their way into these distributed computing frameworks. So that's like one big broad thing. The systems world meets the ML world is something that has been a topic of research and collaboration at Berkeley since my entry to the university in 2007 in the RAD lab. There were systems professors working in the cube or in the same cube as machine learning professors, and this really has come to have an impact and fruition through the way that we've built our open source software. Spark started as more of a systems project where you could just manipulate data like you would with a typical programming API, a functional language API, in maybe a command, a shell, or just a classic Java or Scala application. But in the last 2 years, we've seen a dramatic shift towards interactive queries using tools like R and Python pandas, which are these things that, or even the MATLAB alternatives, open source or MATLAB, and the integrations between these cluster computing frameworks, not just Spark, but the Spark's competitors, which there are in the open source world. Flink, Apache Flink is another one that's very similar to Spark, that's gaining traction on us, and also Apache Hadoop, which has a variety of components that compete with Spark. These all have the integration points emerging with data science tools. And data scientists are now, who've been restricted for kind of the history of their kind of analytics life careers to a single machine, are learning to take their analyses and spread them across clusters of computers that are running these open source frameworks. So to underscore that, let's take just a quick look at the kind of last three. So if we're on version N, which is 1.5 right now, this is N-1 and N-2. And we saw an addition of the data frames API to Spark. How many people know ever heard of or used a data frame? Just so I have context. So about like a third of the audience. Data frames were made famous in the language S, and which evolved into the language R. And the language R then inspired Python to add a library called pandas. And all of that inspired us to add a library to Spark or an API to Spark that is just the data frames API. And this is a way of taking what was previously simplistic, collection-based objective programming and then adding a tabular abstraction. So now you basically you're adding a schema to your data objects. Pretty exciting in terms to data scientists, which about the third of you in the room might find that exciting. The other third are probably struggling to stay awake. And then we added a machine learning abstraction and the language R integration. Language R, just as a signal to how big data and data science interplay, has become a much more popular language. Though it's very old, the tail goes farther back than this. You can see that in the last 2 years, and especially the last year, since 2014, it's become a much more popular language. And so we've decided to integrate, which is another component of these open source ecosystems, that they're much more likely to integrate because the competition is just not the same. You don't see the same dynamics in competition. It's a much more collaborative sort of coding environment. So if that's just the technology itself, then you want to ask the question, how does the technology impact our economy or commerce or more specifically enterprises that adopt the technology? Well, I can only again talk about Spark. That's the company that I'm working at's main product line, the open source project we support. But we have over 1,000 active users company-wise of Spark, including at this point, a majority or a super majority of it, like maybe high double digits of the Fortune 100, and all major companies that do big data have made statements about Spark, and many of the very key ones are integrating with or have their own distributions or partnering with each other to provide distributions. So again, a success story for the folks that were doing Spark, but this isn't the only one like it. Mesos, which was another project that I worked on with Randy in the RAD lab and the NAMP lab, and Apache Hadoop all have similar success stories. And then in the enterprise, you want to look at how are these actually getting adoption. And for those of you who've done distributed or cluster computing, a petabyte job is pretty cool, and having 8,000 nodes is a significant distribution, and not that many frameworks have been built or need to really be built to scale up to order 10,000 nodes. So one final trend on the enterprise side, and then I'll conclude with a thought about education. That I think one really interesting thing that we'll see in the next year and a half and 2 years is the shift from a very classic way that enterprise companies manage their data, which is that you have a very federated set of databases, and then you want to do what they call extract, transform, and load all of the data from those federated silos into some common pool, and then analyze that because you can do a much more rich set of queries against it, because you have access to tables that maybe came from HR and came from your web logs and came from the customer success team, or people answering the phones and help and doing support. Classically, we've had to do a job where we copy the data out of these various disparate systems, and that we run that as fast as we can, but that typically is about every night, which means that the latency on asking queries is order hours or days a lot of times, and the queries you can ask, if you care about very real-time sort of analysis, are very restricted. So this ETL phase, in all of us have taken a database class, is kind of a pain in the neck, and we'd like to eliminate it. So the kind of forecast trend-wise is that there's a movement towards this concept of just-in-time data warehousing, which is to eliminate the ETL phase and instead have a tool that lets you look at the data in situ and do the joins and use caching as a replacement for the classical concept of ETL. And so we propose Spark as one of the alternatives to do this kind of in situ just-in-time data warehousing, and eliminate the ETL phase and use memory selectively and wisely in order to take care of the pain that would come with the latency. So it is a different paradigm to work in, but it is one that we are seeing with real customers broad adoption with. And the kind of one interesting component about the architecture of this new architecture we propose that we would call a just-in-time data warehouse is that you then take whatever disparate kind of tools you have, open source, proprietary, cloud-based, on the bottom, and have access to any of them. And you can add new ones just by adding adapters to the platform, which is something Spark is very careful to do. And also take your various types of workloads, because I mentioned Spark does, and its sort of open source competitors offer an integrated API that lets you do streaming, machine learning, batch processing, and interactive queries, and more graph processing, all on one thing. And you get a graph that, like all of us system architects like to build, it looks kind of like an hourglass with your thing in the center at the narrow waist. Randy taught me to build graphs that look like this, or figures. So there's Spark as the narrow waist. I think it was a requisite slide. And then just because we actually have data from hundreds of companies now, which is something also Randy instilled in me, was the philosophy of merging together the work that you do and collaborations between academia and industry, and the value of real data and use cases and disseminating those. Just thought I'd throw in 2 case study slides, randomized, but these are 3-letter media companies that you probably have watched in the last 2 days. The traditional data warehousing, S3, and then Elasticsearch and Kafka, these are all different disparate actual real use storage systems that this media company uses. And this kind of represents the case study of them looking at these various disparate silos in situ using Spark on a very large distribution that they're running with Databricks. And that's the bottom half. And then the top half is another transit company that I'm very sure you've heard of. And they're on the top half using both machine learning and Spark streaming inside of Spark to do integrated analytics across different types of workloads, where previously they would have used some siloed sort of frameworks, even though they may have been open source frameworks. So the value of this sort of architecture at the narrow waist, having a unified workload model where you can write code in one language that does streaming, machine learning, and graph processing, et cetera, and then you can take that unified sort of application logic and apply it to whatever sort of disparate data sets, joining them or filtering or intersecting them as you like. So those are the two case studies that I thought were worth mentioning. And finally, a couple of thoughts about big data in education. I have been leading the education team at Databricks for the last 6 months, actually. And what that means to Databricks, because our primary product is an open source product that we are the leaders of, and that we benefit greatly by promoting as the #1 alternative or #1 option for big data analytics, is that from the education side, we take it very non-traditionally. If you go to a SAP or any one of the Fortune 100 that are more classic tech companies that have grown into enterprise software companies, they will often use education or their training teams to teach people how to use their proprietary software. At Databricks, and that what they build is courseware or slides and labs that teach people how to do that are proprietary to go along with the proprietary software, and they charge a lot of money. At Databricks, and they actually make a lot of revenue off of their training. At Databricks, we're not aiming to do that. We're aiming to keep the education very similar to how we did education while we were promoting the open source framework while we were researchers at Berkeley. So this last year, we worked in collaboration with UC Berkeley via edX, which is a large, massive, open online course platform. And a professor at UC Berkeley, who I also had the privilege of working with, in addition to Randy, Anthony Joseph, was the professor that taught the class in partnership with Databricks. And we were able to educate for free 70,000 students registered, and 11% of those completed the class, which are above average completion rates. And Databricks made a very large investment, paying for TAs, paying for the software, paying for the, and sponsoring the faculty that ran this class, but not just this class, also a second MOOC, which we did on data science with a UCLA professor that was recently a postdoc in the AMP lab, to get to snag another 50,000 registrations with a 14% completion rate. So if you talk to edX, which was obviously, Berkeley's a part of edX, and edX was kind of co-founded by, or founded by an MIT professor in conjunction with Harvard. It's these top universities who get the idea of open, the concept, the philosophy of open, the same way open source software inherits that philosophy and applies it to training. And Databricks, having its roots both in academia and in open source software, it follows very naturally that we would just be part of a partnership like this. So MOOCs are one form of our education strategy, but also we open source all of our courseware. So our slides and our labs are all open source and works very well from a business perspective, because what we're trying to do is drive people to our platform. And because that platform's open, whether they download it and run it with one of our competitors or not, because other people support Spark besides Databricks, it's still growing the overall pie. So there's a variety of ways to play the open strategy, which benefits the world and aligns with our philosophy and morals, and also supports our business model, which I think is very inspiring to me to work at a company that got that from the Berkeley heritage. And then finally, one anecdote, that my girlfriend is a professor at Harvey Mudd who was also in the AMP lab and had an opportunity to work in the same group that we worked in with Randy. And she's teaching undergrad students databases and systems and at Harvey Mudd. And she also has a clinic project, which is at Harvey Mudd, every senior before they graduate in computer science has to partner with a real world company and deliver like a statement of work and then an actual artifact project for that company. And the one that, so there's a set of liaisons, and the students have to have weekly meetings, and there's a project lead. It's a very cool system to get students working with industry, something that I did with Randy and inspired by Randy as a grad student. The project that was assigned to the students by this particular company in LA was to build a ETL data pipeline. And so the first thing the students did was Google around, and they considered Spark an alternative, but there were many other options. And it was sort of looking at all of these open source frameworks in the context of this company's demands on them. And the interesting thing about this story, if I can remember the interesting thing about it, I hope I can remember the interesting thing about it. I might have to look at my Evernote to remember the interesting thing about it. Yeah, and then I won't take any questions. Yeah, I think that since I haven't met most of you, I'd like to tell you the interesting thing about this story in person. So find me after my talk, and I will...
Any questions?
So I wanted to touch, I guess, come back to something Andy raised at the very beginning, I want to come back to something that Andy put out at the very beginning, which was this interesting question about this mix of leading edge and trailing edge on open source. And looking around in the audience, we've got the primordial open source BSD, right, which, had a trailing edge of trying to get virtual memory into something that wasn't VMS, and then, all this TCP/IP stuff and Sprite and relational databases and app servers in so many places. It seems that in many cases, in fact, leading-edge technology comes out of open source, but by the time it scales, or so often the perception on the industrial side is it's a cheaper version of what's been established industrially, trailing edge, and even Spark needed big tables and Hadoop and whatnot. How do you think? How does the world come to understand that nuance that leading edge technology and trailing edge technology are both part of open source? How do we move that conversation?
Can you state what you see as the fundamental conflict?
Well, I think you're right that the perception is open source is great because it's free, it's cheap. That so often and yet you've, for example, pointed out all these places where it's not just that, it's vibrant, it's leading, it's where new concepts get introduced that are really, changing the technological landscape. But of course, people don't use it in widespread perhaps until it's also big. So have we failed to articulate that, or is it just such a subtle nuance that we have to smile? And
when you say failed, do you mean that in the progression of getting more widespread adoption and claim to fame as the primary alternative for open source? I don't think we failed to articulate that. I think you just articulated it, but I think there's a...
Yeah, easier in this room, perhaps.
Right, yeah. And probably easier in Silicon Valley, and then less easy as you move concentric rings away from Silicon Valley. So I do think that we've kind of crossed some threshold, and we probably in this room crossed that threshold back in the 60s or something, though I wasn't around then. And maybe it's just how fast we can push those ripples out. I don't know. Before I let George start, I did remember the 30-second ending of my story, which is that these students really struggled to understand how to glue together these open source frameworks and to do big data at all. And it's not actually part of the curriculum at Harvey Mudd, but because of Randy and a lot of the innovative thinkers and professors here at Berkeley, it is part of our curriculum. Not per se Spark yet, but the concepts of big data, working with these open source frameworks and technologies. It is one of the side effects of professors like Randy and Randy's vision of having open source and keeping people at the edge, and one of the benefits, not just side effects, of professors working on these projects and releasing the things that are having an impact is that the undergraduate students that come through, they learn about them directly. The courseware actually gets updated within, in this case, months or a year or 2 years after the framework became popular. Hadoop MapReduce is what the students here learn in, I think, in one of the 61 classes. And I think that's another way that at Berkeley, the precedent is set, and then the other schools and universities, top universities and second-tier universities, follow suit. So I want to pay homage to Randy's vision and the other professors in the department for that sort of impact on education as well.
Thank you.